So we are back looking more at the periodic table of the elements. So when we look at that periodic table, we have it broken down kind of like this. We have groups 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to break out these large blocks, A, B, and C. So group 1, except for hydrogen, is what we refer to as the alkali metals. Group 2, alkaline earth metals. Group 3, the boron group. 4 is the carbon group. 5 is the nitrogen group. 6 is the oxygen group. 7 is the halogens. 8 is our noble gases. Now this giant block here in the middle, that is our transition metals. And then we get down to the rare earth metals, the lanthanide series and the actinide series. So everything that we really need to know about the elements is given based on where they're at in the periodic table. So we know that the vertical columns are called groups. Those columns also tell us how many electrons are in the outermost energy ring. Those are known as valence electrons. Those are the ones that are reactive. So there are going to be 8 main groups right here in our color coding system. So each column is called a group, and the group number is going to tell you how many electrons they have. So group 1 has 1 electron in the outermost. Group 2 has 2. Group 8 is going to have 8, so that's why it's full and happy. Except for helium, helium has 2 electrons and it has a full s orbital at that point. So we've already looked at these names. So oftentimes we are going to, instead of numbering them like here with traditional numbers, we use Roman numerals. So you will see that on periodic tables. Now our horizontal rows are called series or periods. They're telling us how many energy rings or how many energy levels an atom has. There are 7 of those. So each row is a period or a series. That tells you how many energy levels. So first period has 1 energy level. Second period has 2, third has 3, so on and so forth. Now it's important to note that with the lanthanide and actinide, you'll notice how they should slot into this little white space right here. So this row is continued with this top row here. So elements in the same period are going to have the same number of energy levels. Elements in the same group are going to have the same number of electrons in their outermost. So if I was going to look at an element like potassium, knowing that it is in the first group tells me that there is 1 electron in their outermost shell. Knowing that it is in the 4th period tells me that there are 1, 2, 3, 4 levels. So we know 1 valence electron and 4 energy levels. So that takes us to probably what is considered the most important rule in chemistry, which is that all electrons are going to react in order to have a full 8 electrons in their outer energy ring. Metals give electrons away to give 8. They want to get rid of them, slough them off. Nonmetals are greedy. They want to take them to get 8. They're close to having 8 and they just want that 1 extra. They're like, can I have a quarter? Just give me that extra electron. So here I have sodium. Sodium is a metal. It is going to slough that electron off. It is going to kick it out, loan it out to another element in order to be left with this shell right here that is full. So you'll notice that that makes sodium then positively charged. It makes it a cation. So what frequently happens, one of our most common chemical compounds is sodium chloride, table salt. So chlorine has 7 electrons in their outer valence shell. Sodium has 1. So sodium is going to slough it off and bond with chlorine by giving up that extra electron. It forms a type of bond that's called an ionic bond. So there's a lot of other elements that can bond this way, and we will get into bonding. There is a lot of information here. So chlorine and calcium can bond. Calcium can take and donate a electron to each of these chlorines, and that gives us a bond, if you will. Lithium and chlorine. Lithium can slough an electron off and again give that to chlorine and share. We get magnesium chloride. So when I look at reactive elements, it is easier to give away 1 electron than to give away 2. So sodium only has to slough off 1. It is going to be more reactive than magnesium, who needs to give up 2. Part of that is because once I slough off 1 electron, that magnesium atom is going to become positive. And that positive charge is going to hold tighter to the other electrons. So it is going to be easier to just take that first one off. So here I have carbon. So we are in the 4th group. So that tells me we have 4 valence electrons. It's in the 2nd period, so that tells me we have 2 energy rings. Sodium, we are in the 1st group, so that's 1 valence electron. We are in the 3rd period, so we have 3 energy rings. So try this. We are looking at neon. It is in the 2nd period, so that's 2 energy levels. It is in the 8th group, so it has a full 8 valence electrons, so that's what it's going to look like. Hydrogen, it is in the 1st period and the 1st group, so it has 1 electron and 1 energy level. Potassium is in the 4th period, so that tells me it's going to have 4 shells, and it's in the 1st group, so that means we have 1 valence electron. So when I look at the orbitals, the 1st and 2nd groups have their last electron in the s orbital. That's where their valence electrons are, is in the s orbital. Our transition metal block right here, these pink ones, going down to these 2 as well, those are in the d orbital. So you're ending in the d orbital area for these ones that are pink here. If I look at helium, helium is S, but everybody else that's in the tall ones on the right, they are ending in the p orbitals. And then down here, everybody past lanthanide and actinide, those yellow ones, yellow-orange, those have their last electron. All of their valence electrons are in the f orbitals. So knowing where we are at in the periodic table tells me the last sublevel, the last shape that we put the last electron into. So if I go back and I look at potassium, we have 1 valence electron, we have 4 energy levels, and because it is in this first block, that 1 electron is in the s orbital. So our last electron is 4s1. So we are going to get more into bonding and how this all works